question 25 says we have like 1-inch squares that are cut from the corners of a 5-inch square. And we want to know what is the area in inches of the largest square that can fit into the remaining spaces in the remaining space. So this could be a pretty tricky problem. Like we might see, oh, so we have like this square with like some of these corners removed, so we have to like ignore these, right? Like we can't like use these squares. So we might say, oh, so then that means the largest square must be the center square, right? We must have like, we must have this square in the center. That must be the largest square, right? So like if each of these squares has side length 1 and the big square has side length 5, then this is 3. So we would do 3 times 3, which is 9. And we get like choice A. But like the problem with this is like, first of all, maybe you should realize, oh, well, this is a question number 25, so it should theoretically be the hardest one. And like if you just did that, that would feel like kind of too easy for number 25. And also, whenever you have like a multiple choice question and like the question asks like, what is the largest like possible thing? And notice that 9 in this case is like the smallest choice. Like that should make you like uncomfortable. Like sometimes like if something asks you like, what is like the maximum possible value of something, and you get the smallest answer choice, like the other answer choices were like 12 and a half, 15, 15 and a half, 17. Normally you'll see like the answer choices arranged in like increasing order, just like a fun fact, maybe decreasing, but usually increasing order. So it asked for the area of the largest square and you got the smallest value. So that should feel kind of like suspicious. And similarly, if the question asked for like the smallest value and you got like the largest in the answer choices, you should also be suspicious. Of course, like you could be correct. Like it could be the right answer. You should just like, it might just be a good idea to like double check just to make sure you didn't like accidentally miss some like tricky thing or something like that. Of course, if they asked for like the largest possible thing and you got the largest choice, then you can be extra sure that you did it right. But yeah, that's just a quick side note. So the reason this square isn't like the largest possible square is because you can kind of like tilt the square so that like the square is kind of like not like straight, not like straight upright. Like you can kind of tilt the square into like this. You can kind of tilt the square like this, right? Like the reason this square will be like bigger is because like you're now taking up more space. You're like using your space more wisely. So this square, this red square, should be our maximum area now because we're taking up as much space as possible. So now like let's see, how can we find the area of this square? So we know that like each of these corner squares has side length 1. So this has length 1, this has length 1, this is length 1, this is length 1. Now, if we drew in like our previous square, like this 3 by 3 middle square, like 3 by 3, like we originally found like this already has area 9, right? So it has area 9, the middle square. Now, to find the area of the red square, we only have to find the sum of the areas of these 4 red triangles. And to find the sum of the areas of these 4 red triangles, we only have to find the area of one of these red triangles, because by symmetry, once we find the area of one of these red triangles, we can just multiply by 4 to find like the area of all 4 red triangles. So let's like focus on like this triangle at the very top. Notice that 3, you have the number 3 here, right? This is 3. So the base has length 3. Now you have this like 1 here. Like you can kind of think of this 1 as like the height of this triangle, right? So this 1 is like the height of this like red triangle, and like 3 is its base. And its base has length 3. So to find the area of this red triangle, like this red triangle, then we would just do a half base times height. So it would just be 1/2 times 3 times 1, which is going to be 3 halves. So that's the area of one of these red triangles. And since we have 4 of these red triangles, we would do 3 halves times 4, which is equal to 6. So 6 represents the area, the sum of the areas of these 4 red triangles. And to find the area of the entire big square, like the one I outlined in green, then we would just do the sum of the red triangles plus the blue square. So you would just do 6 plus 9, which is equal to 15. And that would be choice C, and we would be done.